Hello and welcome to this lecture on convolutional neural networks. We'll see what CNN is and all the components of a CNN network. So, convolutional neural network is a specialized neural network. It is designed for grid-like data structures. They use convolutions, which is a mathematical operation for feature extraction. We'll see what convolution is in a little while. Convolution basically involves sliding a filter or a kernel across the input to detect spatial patterns. The operation includes element-wise multiplication and summation, producing a feature map. So the output of a convolution operation is a feature map. Primarily, it is used in image processing for detecting edges, textures, complex features. It can also be applied in 1D, one dimensional data like signal processing, which is beyond image data. So, first we see the convolution operation. It is the element-wise product between a filter and the local input region. So, consider this is the input. Now, will be of type input will be of type image. Okay, so this is a binary image, a binary data of the image, and this is our kernel. So what happens is we take this region and multiply it with a kernel, which will be some specialized values. Okay, so there are specialized kernels to detect all these things, as we have seen over here. uh, that is it was mentioned that for detection of edges, textures, complex features, there are specialized uh, kernels which can be helpful. Okay, so what happens is we multiply each of them with the specific values, that is 1 into 1 plus 0 into 2 plus 3 into 1 plus 0 into 4 plus 5 into 1 plus 6 into 1 plus 7 into 1 plus 0 into 8 plus 1 into 9, and that comes out to be 31. Now this is a purely mathematical operation. There is uh, there is some logic to it, in the sense that some filters we have seen that there are some filters when they are applied to a particular uh, image, it results in detection of certain features. So those features are edges, like edges, textures, and other complex features. Okay, next we come to the pooling layer. In pooling layer, what happens is, suppose that this output turns out this output turns out to be these values. So we decide which value will be carried forward out of these four. So maybe if we consider max pooling, that is consider the maximum of these four numbers, then 12 will be carried forward. From here 7 will be carried forward, 13 and 14 and so on. Okay, so that reduces our spatial dimensions. So what basically happens is, instead of 4 by 4 matrix, what we are passing here is 2 by 2 matrix. So pooling helps in reducing the spatial features, summarizing important information. Common pooling types are max pooling, which retains the maximum value of the each region. Pooling aids computational efficiency and focuses on key features. Pooling contributes to translation invariance in hierarchies. The choice of pooling size impacts the level of spatial abstraction. Proper pooling enhances robustness to model variation. So we'll see over here, when we pass this image of zebra, what happens is we pass it to a convolution layer, then a pooling layer which reduces the dimensions. As you can see, the dimensions are reduced over here. Then again a convolution and pooling layer, then again a convolution and pooling layer, and finally we have this minimized sized of data. Now each of these uh, arrays contain a special information about this zebra. Now, some might contain the information about the edges, some might contain the information about the strides, some might contain the information about the texture, and so on. Okay, so this output, what we do is we straighten up the output at the end and pass it to a normal our fully connected artificial neural network, and then that gives us our output, which is a horse or a zebra or a dog. So as you can see, a softmax activation function, when applied to it, it will give you these probabilities, and since 0. 0.7 has the highest probability, that will be of uh, the output is of class zebra, which is 0. 0.7, the second output. Okay, so convolution and pooling operations are basically performed before providing your input as flattened input to the artificial neural network. So that is done for reading or for understanding spatial uh, features of the image. Okay, so this might contain all these pooling layers might contain spatial images features like edges, textures, etc., colors, etc. Right, so that is very important. So it's here it is also written as feature extraction. The process, these process from here, from the input to the last layer of pooling, all this till flattening, it contains feature extraction, and then a normal fully connected layer performs the classification, and the we get our output. So now what about the edges? When we perform the convolution operation as shown over here, the edges are detected only once, whereas the inner data is detected more than once, and this might result in losing of information from the edges. So what is done to avoid this is padding of uh, the padding outside the edges with zeros. So we add zeros at the end of each of the edges, and that results in uh, keeping the edge informations. So padding preserves the spatial information during convolution, preventing the edges data loss. Edge data loss. Zero padding, that is adding zeros, is most commonly used to maintain the input size. The stride controls the step size of the filter's movement. Larger strides reduce the output size while smaller strides increase it. Padding versus stride is a trade-off between efficiency and more information retention. So the more padding you will do, the efficiency will increase. Okay, but stride, if we increase the number of stride, that is stride is how many blocks you move ahead at a time. If you are moving one block at a time, then the stride is 1, and if you increase the number of stride, the efficiency will decrease, and the information retained will also decrease. So now coming up with the how the detection filters are done, which filters are important for edge detection. So there is this Sobel filter. Here you can see the mathematical explanation for Sobel filter. These are this one is useful for detecting the vertical edges. This one is used to detect the horizontal edges, and combined their magnitude is calculated as below. And this is Sobel filter, which detects the vertical edges. This one detects the horizontal edges, and then there is the Laplacian filter, which is this one, which is multiplying this value, which basically detects both vertical and horizontal edges. Apart from these edge detection filters, there are some filters which are popular, that is texture filters, blur filters, uh, features feature filters which detect shapes, curves, and other details, color and contrast filters, object part filters, face human detection filters, there is gradient filters and spatial filters for localization. So after that, we have a specialized kind of network which is used for detection of uh, MNIST data set, which works on MNIST data set and detects uh, the digit given over here, and that is the Lenet 5 network, which has two layers of convolution and pooling, followed by a dense network of 120 neurons, then 84 neurons, and then finally the 10 outputs. Similarly, we have AlexNet, which is a combination of a certain specific combination of uh, convolution and pooling done for RGB images, red, green, blue images, and that is from ImageNet dataset. And the way it works is we have convolution pooling layer, followed by convolution pooling layer, followed by three convolution layers and a pooling layer, and then finally given to 4096 this neurons and 4096 fully connected neurons, and then finally the number of classes which we have in our output. Transfer learning is uh, where transfer learning is where we use a pre-trained model to basically use it for our specialized need. And the way you can do it is you download a pre-trained model, you remove the last layer because that is specific to the problem that it was solving, and then what you do is you retrain it with your specific data, and then you can utilize the model. So these are the three steps: take a pre-trained model, remove the few last few layers, and then fine tune it to your particular data set. Okay, and these are models which are provided by Google, which you can use, right? So this was all about the convolutional neural network. Let's meet in the next lecture.